Here we have question number 37, and this question is from subject heat transfer. This question came in 2011 in 2011 paper of chemical engineering gate. Question number is 37. You can check in the official paper. Now let's read the question. While at 120 degrees Celsius is used to heat water at 30 degrees Celsius in a 1 co-current cell and tube heat exchanger, right? The available heat exchanger area is S1. The exit temperature of the oil and water stream is 90 degrees Celsius and 60 degrees Celsius respectively. The co-current heat exchanger is replaced by 1 counter current heat exchanger having heat exchanger area S2. If the exit temperature and the overall heat transfer coefficient are same, the ratio of S1 and S2. Okay, so first of all, we have done a process of cooling of water while using in a counter current selective heat exchanger, and then we have done the same process again with keeping the parameters same in a counter current heat exchanger process, right? So we have like shifted from co-current to counter current and keeping all the parameters same. Just S1, the heat transfer area become S2, the heat transfer area for second part, co-current counter current part. Okay, so S1 is changed from S1 to S2. Okay, this is we have to keep in mind. Now what we have is while is the first fluid, that is hot fluid. While is hot fluid, that is cooling water, right? So that temperature of while from 122, it decreases from water stream. Exit temperature of the oil and water stream is 90 degrees Celsius. So 120 degrees Celsius to 90 degrees Celsius, right? And the water that is cold fluid, it is and the entering temperature of the cold fluid is water is 30 degrees Celsius, and the exit temperature is 60 degrees Celsius. So heating has done for this cold fluid, right? Now what we are going to do is we are going to write the basic. First of all, see the how this thing is behaving in co-current and counter current fashion, right? So let's draw the graph of co-current and counter current. So first of all, let's draw co-current, okay, and then for counter current. This is very simple question actually. So this is for co-current and this is for counter current, right? So in co-current we have the entering temperature of hot fluid is 120, and the entering temperature of cold fluid is 30 degrees Celsius. The all temperature are in degrees Celsius, and the exit temperature of the hot fluid is 60 degrees Celsius, 90 degrees Celsius, sorry, 90 degrees Celsius, and the exit temperature of cold fluid is 60 degrees Celsius. Okay, now for I am writing it with another color. So for the counter current, we have entering temperature the same, exit temperature, the temperature exit in cold current from this side. So 30 we are going to write here this time, and exit temperature of that hot fluid is 90 degrees Celsius, and exit temperature of the cold fluid is 60 degrees Celsius. Okay, right? So now what we have is we have to calculate LMTD, and then we have to calculate that Q is equal to UA delta T, overall heat transfer coefficient. By using that equation we can calculate further, right? So first of all, let's write that formula. So we have formula, what we know is Q is equal to M cold Cp cold delta T for cold is equal to M hot Cp hot delta T hot, that we can write, and also Q is equal to UA delta T Lm, logarithmic mean. So first of all, what we have to do is we have to calculate, for using this formula, what we have to do is we have to calculate that LMTD, and then what is we are going to do is we will calculate this formula for once for the case 1, that is for co-current, and again we are going to calculate this is for counter current, case 2, counter current, right? And then this the both q, that is heat transfer that happening, is the same that is specified in this question. That means this two equation can be equated, right? So first of all, let's calculate the LMTD for both the cases. So I am going to calculate here the LMTD for co-current and counter current, right? So for that LMTD formula we have delta T LM, we have delta T1 minus delta T2 by LM delta T1 by delta T2, right? Now what we are going to do in co-current, we have to find out what is the delta T1. Delta T1 here is, delta T1 is, for this part delta T1 is 120 minus 30 is 90, right? And for this part the delta T is 90 minus 60 is 30, right? Yeah, that is delta T2, right? So we are going to put that in formula for delta TLM for co-current. For co-current we have 90 minus 30 by ln 90 by 30, right? And similarly we are going to do for counter current. So delta T counter current, delta TLM counter current, what we have for counter current, that is delta T1 is equal to 90, and here also delta T, sorry, delta T1 is going to be 60, and here delta T2 is going to be 60. So 60 minus 60, so this term is going to be 0 if we are going to write 60 minus 60 by ln 60 by 60. So we are not going the delta TLM we are going to go get is 0. That doesn't correct because temperature, there is a temperature difference, right? So for in this case, if we have in a case if we are getting delta T1 is delta T2, then what we do is we calculate delta TLM by taking average of these two temperature difference. So here we are, what we are going to do, this is also a concept. If for delta TLM is getting 0, delta T1 is delta T2, what we are going to do, we are going to take average of these two, right? So 60 plus 60 by 2, 60 plus 60 by 2, that is obviously going to get 60, right? So LMTD for counter current, delta T LM for counter current is going to be 60, right? So the counter current delta TLM is 60, and the co-current delta TLM co co-current is going to be 90 minus 30 is 60 by ln 3. By calculating this, we are going to get 60 divided by ln 3, that is 54.6, 54.6. Okay, so this two value we got. Now what we are going to do is we are going to use this value here in this equation. So we are going to use this value here. How we are going to use this? For co-current for co-current case and for counter current case, right? So for co-current case, what we are going to do, Q is equal to U, A is S1 given, S1 delta TLM in this case, and Q is equal to U S2 given and delta TLM for counter current. Now this is equation 1 and this is equation 2. Now after that, this is equal to U S1 delta TLM is 54.6, 54.6, and here U S2 and delta TLM is 60, right? Now equating 1 and 2, equating 1 and 2, we are going to get U S1 54.6 is equal to U S2 60, right? And U is same that is specified in question. That means S1 by S2, that what it is asked, the ratio of S1 to S2 means S1 by S2, and that is going to be 60 by 54.6, and the answer we are going to get is 60 by 54.6, that is 1.0, 1.09, 1.09. So that is approx 1.1, and that is answer. Now see the answer, that is 1.1. So this is the correct answer, and this is a very basic, actually this is a very basic of heat transfer subject, heat exchanger. In heat transfer, this subject is this topic is from heat exchanger, and in which we equate that heat duty equation from the heat transfer that is occurring from hot temperature to cold temperature, right? So this is a very easy topic from this question, from where the question is asked. You can see that solution. Okay.